one of them I'm laughing real hard at Q. But I couldn't take it out, so it's okay. We're going to start today on our review for final on number 44 on our sheet. And it is solving trig functions on a defined domain of angles, 0 to 2 pi, radian measure. So we have f of x, if I can find, oh, there I am. F of x is equal to 2 cosine theta plus 1. And we're solving for f of x equal to 0. So this means that the y, which is f of x, is 0. So we're going to put 0 equals 2 cosine theta plus 1. We're going to isolate the theta, and I'm going to have a negative 1 is equal to 2 cosine theta. I'm going to divide by 2. And now I have that the cosine theta, being in this radian measure, has to equal a negative 1/2. All right. So we're talking about the whole part. And we're talking cosine is negative. So cosine is negative in quadrants 2 and 3. All right. And what we would do is state this as inverse cosine of 1/2 is equal to theta. Because if we multiply cosine theta by inverse cosine of theta, they're inverses of each other. And we are asking what is the value. Okay, so in this case, we're talking the square root of 3 over, I'm sorry, 1/2, and the square root of 3 over 2. This is a negative 1/2 and the square root of 3 over 2. And this is a negative 1/2 square root of 3 over 2. And I know it looks like 45, but it's not. Sorry about that. We know these values to be, if sine is the larger, right? So what is it? Well, this is pi thirds. This is what? 2 pi thirds, because we're in quadrant 2. And this guy is what? 5 pi thirds. Right? Are we good? Okay, so we're saying these two guys are the angle measurements that give us cosine as a negative 1/2. Is everybody good? Yes.
How do you know you keep it in radians of degrees? I kind of don't know.
What did you ask me? How do I know if?
Yeah, so it says solve the equation on the interval. How do we know to keep it in radians or degrees there?
Oh, okay. If any 2 pi happens, it's radian. Or pi, or any of those two symbols, it's radian measure. Degrees are specific. That's an excellent question. Degrees are in 0 to 360, and the degree symbol would show up. No, this was definitely radian.
So I did the inverse cosine of negative 1/2 and I got 120.
Well, that would be wrong.
So,
It's in radian.
so when it says, right, we solved it, okay, solved the f of x is 0. So the answer is just the inverse cosine 1/2. And then we would just double check that it was correct.
You just, actually, you can stick it in. You can stick it on your home screen so long you're in radian measure, because that's a good point. Okay?
Yes.
Clint, that is a very good point. Remember, the original is 2 cosine theta plus 1.
Right.
So we need cosine to make it negative.
Right.
Well, at cosine is any one of the two, you're going to have negative 1/2.
Correct.
times 2 is a -1. We have 0. And you can do that on the home screen.
Yes.
Yes.
Isn't that the inverse cosine of -1/2?
Yes. Sorry. Thank you. Okay. I just didn't finish.
No, we're cool.
All right. Does that make sense?
Oh, absolutely.
Please utilize once you know the radian measure, stick it in and you'll get the outcome. So you can double check all the time. Yes.
Sorry, I'm on the bottom. The circle chart that we have, are we able to use that for the final as well? The
Well, Clint says he can put it on there.
you gotta redraw.
Okay. Now, at some point, Cody, you're responsible. And I don't know. It would be bad for you not to know it. In your profession. In yours. If we were going only for science, it don't matter. Because they don't even deal with movement. They deal with count. They do counts. And you're drawing shapes using a function on CAD. And that means if you don't know circles, you're not going to make that little shape happen. I'm just telling you. Okay, I'm good. My rule is if you can put it on the card, it's okay with me. Please make sure you read the announcement. Okay. All right. 45, we have another one. And again, we're looking at radian measure for our restrictions to domain of theta. And then we have 2 sine squared theta equals to sine theta. All right, so in this case, we're going to set it, it's a quadratic. So therefore, I'm going to have 2 sine squared theta minus sine theta is equal to 0. Now I'm going to factor out a sine theta. Oh, this is a minus. I'm sorry for leaving off stuff. Okay. So now I have my 2 factors equal to 0. So sine theta has to equal 0, and 2 sine minus 1 has to equal to 0. Okay, is everybody comfortable with that? All right. So now we're going to do the inverse sine on this one. The angle whose measurement is 0. And then this one, we're going to isolate the sine. This time it's positive, and I'm going to divide by the 2. And now I'm going to do inverse sine on both sides. All right, and I'm going to draw my pretend radian measure unit circle. All right, and we want sine is 0. Well, sine of 0 is here. And for it to be a half is on pi 6, right? To be a half, because that's the square root of 3 over 2, and it's positive. So we would have it here and here. And this guy is 5 pi 6s. negative square root of 3 over 2 and 1/2, positive square root of 3 over 2 and positive 1/2. Again, looking at the ordered pairs of what we have. So on the 0, we would have our 0 radians and pi. So our set would have 4 of them between the parameters that they gave us. It would be 0, pi 6, 3 pi 6, no, 5 pi 6, if I could write, pi, and that's it. Those are the 4.
That's in between.
Yes. Okay. All right. It's been a while. That's a song.
Yeah.
Here, we're putting things in their basic units. Okay, so we have cosine theta into 2 terms that are in the basic form. So what is the identity for cosecant theta? Sine? Isn't it sine? And we're going to distribute that through and come up with the identity for this guy. So I would have 1 over sine theta times sine theta plus 1 over sine theta times, and this is cosine theta. And these cancel, so I have 1 plus, and this is what? Cotangent theta? Are we good? Well, I'm hoping we're good. Okay, 47, 48. What do I have on 48? Is it the same? Oh, I'm on 47. Find exact values. All right. This is formulas. This is a sum or difference. And that I would put on my card because I don't know them by heart. Okay. And but we would have to have the sum and difference. And pull out your identity card and give me that. And this would have to be, if I had pi 11 pi 12ths negative, and it's sine, and sine is negative sine of 11 pi 12ths because it's odd. Okay, so what would I write? Okay, that would be pi, and we're talking 11. I guess we'd have a sum of, let's do, what would it be? 6 and 5 won't work. So we're going to have to do weirder. 10 and 1. 1 12th? No. I need at least a 2. A 2. And that would give me 9. That one will work. And it's a sum. 9 plus 2, 9 pi, times 2 pi on 12 will give me 11 pi twelfths. Okay, so I need the rule for sum. It's just a rule. Because what we end up with is the sine of 3/4 pi plus pi sixes. And we know those values. Now I need the formula. Get out your sheet. And that's one of the ones you need to put on your thing. On the big sheet with the wheel, the circle. And it's sum of two angles.
Special angles.
I didn't write them before it came in. Alrighty. I'll look it up. Like I said, I didn't bring anything very, very prepared. All right, let's see what I have here. There they are. It's sum and difference formulas, and on sine, it is sine A cosine B, cosine A sine. Okay, and it's plus or minus, so it's plus plus.
Yeah.
And I couldn't remember. The other one is sine, sine, cosine, cosine. That's what it is. All right. Okay. Oh, all right. And you need to put that on your card when you get to your getting it organized. Now remember, organize it in the order that you need to have it in, and that'll help. All right. And we know it's negative because of the rule on sine. Sine is odd. So if I have a negative movement, I can change this negative to the outside and keep the number positive. And I have that up here too. Hold that thought. Oh, it's giving me a thing. Hold that thought. All right. And even odd should probably be one of the ones that you keep. And it's right here. See it right? This is the one I quoted because I know it. The sine of negative theta is negative sine of that theta. So, because it's an even odd, and in cosine it's even. So it becomes, you see it?
No, I see it.
Oh, okay. And that should have been, we discussed that in class. I know we did, because that's crucial. All right. So now that I have my rule, and I'm going to write what I need. I'm going to have the sine of 3 pi fourths, and then the cosine of pi 6, plus the cosine of 3 pi fourths times the sine of pi 6. All right. Okay, on 3 pi fourths, okay, that's at negative square root of 2 over 2 and square root of 2 over 2, because sine is positive. And on pi 6, they're both positive. It's quadrant 1. So that would be the square root of 3 over 2 and the 1/2. Okay, is everybody comfortable with that? So the sine of this guy is the square root of 2 over 2. And the cosine of this guy is the 1/2. Okay, now the cosine of that is negative square root of 2 over 2. And the sine is the square root of 3 over 2. Now we're going to do the math. And then we're going to have that common denominator. And we're done. Are we good?
It's not -7/4 over 4.
And, oh, thank you for that. And the whole thing is negative, so I have to change all the signs. Good going. Good going. All right. Sorry about that. Now, I'll accept this, and I'll accept what the answer key said. It factored out the square root of 2 over 2. But I'll accept whatever you give me. All right. I am on cosine of 5 pi 12ths. All right. So immediately I know it's a plus or minus, right? And it's a small amount because I would only have 2 and 3. Well, it's okay. I can make it a plus. 2 pi 12ths plus 3 pi 12ths is 5 pi 12. So I can make it a plus. So I can say the cosine of 2 pi 12ths plus 3 pi 12ths. Okay. And that would simplify to the cosine of pi 6 plus pi fourths. All right. So this is what I'm using to make this happen. Is everybody comfortable with that?
Yeah.
On our sheet, on the cosine for plus, we've got cosine, cosine, sine, sine, and its opposite sign. All right. Okay, and we know they're both in quadrant 1, which makes them both what? Positives. So in pi 6, we have the square root of 3 over 2 and the 1/2. And in pi fourths, we have the 45 degrees. So we know they're both the same of square root of 2 over 2. Okay? All right. So I'm going to now insert what I want to work with, the cosine of pi 6 plus pi fourths. And it doesn't matter which way we work it. Is that clear? Addition is commutative, so that we can flip them if you want. It doesn't matter to me. So I'm going to have cosine of pi 6 times the cosine of pi fourths minus the sine of pi 6 times the sine of pi fourths. All right, now I just insert the exact values. Not a big thing. The cosine of pi 6 is the square root of 3 over 2, and the square root of 2 over 2, minus, and for the sign of it, I got the 1/2 and the square root of 2 over 2. And they're going to factor out that square root of 2 over 2, so I'm going to do it this time. And that'll leave me the square root of 3 over 2 minus the 1/2, which turns out to be the square root of 2 over 2. And we're going to have the square root of 3 minus 1 over 2. And that, but like I said, I'll accept the multiplication of it. Okay? Alrighty then. And we're solving triangles. Any questions on this? Oh, I forgot to write the number. Any questions on this? Okay. On 49, we have a drawing, and it's a scaling. And this guy is 100. This guy is 35. And this is an 8. This is an A and a C, and this is, and we got, oh, and a Y. All right. So when they say solve the triangle, that means anything that's missing. And we know we have the sum of the triangle, the sum of the degrees in the triangle is equal to 180. So I have 35 degrees plus 100 degrees plus y degrees must equal 180 degrees. This is 135 degrees. I subtract that and I get what number? All right, so we have all three angles. This is a 35 degree, 100 degree, and 45 degree. Okay, so now we need all sides. I only have one side, so I can use the law of sines. Those are ratios. All right, so I can have the sine of 100 is to A as the sine of 35 is to 8. All right. So we cross multiply. And then divide. Once we get here, we stick it in the calculator after we check the mode. Very tricky, okay? So we have to check the mode. All right, let me pull up my calculator. I didn't bring my beverage. Come on. I think my calculator's tired. Ah, there it comes. Are we okay? Okay. There it is. It's coming. I'm sorry. It didn't get ready for you. So I'm going to go in my mode, and it's in degrees. So that's where I was working on. Okay, it's in degrees, so I'm good. So I'm going to put the sine of the 100. Oops, wait. Let me clear that. I think, let me go over here to see my problem. Do it exactly like I have it. 8 sine 100, close parenthesis, divided by sine of 35, close parenthesis, and enter. And I think we're going to do 1 decimal or 2. 2 decimals, sorry. 13. Let me do view always in front. 1374. All right. So now we have that. So we're going to figure out the last one. The last one is opposite that 45. So I'm going to do C is to 45, sine of 45, as, and I'm going to put the 8 over sine of 35. That way, I just have to multiply and get there. Sine is 8 sine 45 divided by sine of 35. Is everybody okay? All right, I'm going to enter it. Now remember to close your parentheses. That's the only thing that will make you have an incorrect solution. Carelessness, right? Details. And we're going to have C is approximately 9 86/100. So we had our degrees and we have our sides. 8, 13, and 74 is what I got, and 9 86. How we doing?
I remember that one. That was really fun.
Solve the triangle.
Yeah, sine is the best. I love
What
sine.
I don't like is when somebody has to long, you know, it doesn't matter now what you put on the test. You know, like which one has 2 triangles? That thing. Yeah.
Ambiguous case.
Yeah, that one I never got.
Well, you don't have it on the test.
Good. Let's not worry about it.
Because I did the best I could. I did what the book wanted. Okay, so on this one here, again, we have our Y on the top. We have 20 degrees on the left base and 110 on the right base. And we're given 8 and, oh, I'm sorry, my eyes dropped. I apologize. This is C, A, and 10. Do I have it right? Yes. Okay, we're going to first calculate the missing angle. That means I'm going to have the 20 degrees plus the 110 degrees plus my Y degree has to equal to 180 degrees. This is 130 degrees plus the Y degree has to equal 180. I subtract, so what is my Y degree? It looks like 50. So I have all 3 angles. My angles are 20 degrees, 110 degrees, and 50 degrees. All right, so I got all my angles. Now I'm going to use law of sines. And I'm given this one. So I'm going to put 10 is to sine of 20 as, and I'll go A is to sine of 110. All right. So this means I multiply by this guy. 10 sine 110 divided by sine 20 has to equal 8. Is that good? All right. I'm going to enter it in my calculator, making sure I close my degrees on my numerator. Oops. Hit the run. It's sensitive today. 20, and I'll hit enter. And this is 47. Okay, Now I'm going to use my 10 over sine 20. I never use my approximations because the approximations get worse. Always use your definite. Never ever alter that process. And you'll be mad at me when it's wrong. Okay. So I'm going to use that one. And now I want C over sine of my new number 50. Okay. All right. So I'm going to have 10 sine 50 divided by sine of 20 must equal approximately the C. All right. 10 sine, and I think I only gave you sine because nobody messes up on sine. The cosine is a little more involved. You got a squared plus c squared times minus 2ab cosine angles. Yeah. Okay, so I don't think I did one of those. No, I didn't. Well, that's good. Okay. I'm being nice to you. Sine of 20. All right. And it's approximately 22 and 400ths. And now I have all three. This is, let's see, we had 20 was 10. 110 was 27.47. And our last one was 22.4. Okay. Okay, we have one with a listing. No. Yes. Oh, no, I have one more triangle drawn. Now remember, I stink. Oh, this is cosine. I lied. Sorry about that. This is cosine. Because I don't have two angles. Okay. We have, and I don't have two sides. Oh, yeah, we do. Okay. We got this guy and no. 35 is B. And alpha is 2. And 8 is Y. We're going to have to finagle this. So we only have the degree of B. And I have two sides. This will work. B squared is equal to A squared plus C squared minus 2. And let me verify. 2AD, AC, cosine of 35. But let me verify. I'm pretty sure I'm right, but don't want to mess up your notes. My here doesn't have the law of cosines on it that I can see. Hold that thought. Wait, I didn't go far enough. Yes, 2AC cosine B. I just want to make sure. All right. B squared is equal to 2 squared plus 8 squared minus 2 times 2 times 8 cosine of 35. Alrighty then. We had this conversation. These are obtuse angles. They're not, do you see a right angle notation? No. No assumptions ever. Ever, ever, ever. Okay. All right. Now I'm going to stick it all on my calculator. Okay. let me do one thing here. Let me copy, capture screen. And I'm going to stick it right there. Oops. There you go. Oops. Got a little carried away. There we go. Okay. Now I'm going to work on this one right here. 2 squared plus 8 squared. Oops. Oh, clear that mess. I had an answer there. Oh, sorry. 2 squared plus 8 squared minus 2 times 8 cosine of 35 degrees. And now we're going to take the square root. I'm sorry, I didn't do the square root on it. Second square root, second answer. Thank you. Let me just put it in. Sorry about that. Didn't do it. It was too hard on it. I don't know. It doesn't like me, I think. I'm going to do the 79. I'm going to do the 787, just to be careful. And that is the answer they have. Okay, now that I have this, I have the B. I can do this as my identity for sine, because I need an angle. I'm going to do 6.46 is to sine 35 as, and I have my A, 2 is to sine A. All right, so I'm going to, I wrote it wrong again, but that's okay. I'm going to do cross multiply to make sure nobody gets confused on my math, on my shortcuts. I'm going to divide by this number. So we want A equals sine inverse of this guy. Okay, because we need the angle. Okay, all right. 2 sine A, okay, yeah, I got it. Here we go. All right. So I'm going to clear this mess, and I'm going to hit second sine, and I'm going to enter 2 sine 35 and close parenthesis, and close it again, because I'm dividing. Divided by the 6.46, and oops, what did I do? Oh, I didn't need it. Sorry about that. Didn't need it. And I didn't have to do 2. So then we have our angle is 10.23 degrees. A. And they put just 1 decimal. Okay. All right. So then, okay, so now I have this angle. Okay. I could use a multitude of things on this. because we've got everything that we need except for the one angle, which is y. And it's easier for me to do it under sine than it is cosine, because there's a lot of numbers on cosine. So I'm going to use sine again. I'm going to do sine.
Question, who is subtracting?
I'm sorry?
Who is just subtracting 300 from 180?
Oh, damn it, yes.
Who do you move the one?
Yeah, I was making it hard.
Right.
I just wanted to use sine again. So we got two angles. We
Right.
have
You
subtracted
just
from
subtracted
one
180.
angle.
Yeah.
Ah,
I was about to say, I was like, wait a minute.
oh, I'm into the math.
Yeah, I'm doing the same thing right now, it's fine.
But I was doing the math.
Yeah, but I'm like all about shortcuts.
Yeah. Absolutely. Okay. So what we have here is our 35 degrees plus our 10.2 degrees plus y degrees has to equal 180 degrees. 45 and 2/10 degrees plus the y degrees has to equal 180. If I subtract, I'm going to get 8/10, 9 is 4, and 3. 134? Okay. Degrees, and I got them all.
And that's right.
I sure appreciate that. Okay. All right. Now we're doing limits. Algebraically. I would have gotten the same thing. I just want you to know. In my dreams, right? I don't know. Okay, we got 53. And we want, any questions? Okay. I apologize. Limit as x approaches 2 of a polynomial. What do? No.
Just plug it in.
Plug it in. That's right. Okay, and that's all we do with it because it is continuous, because the domain is negative infinity to infinity, and continuous. Because it's continuous, that's all we do. So we're going to have 2 cubed plus 5 times 2 squared minus 7 times the 2 plus the 1. This is 8, and this is 420, and this is negative 14 and 1. This is 28 minus 14 is 14, isn't it? And plus 1 makes it 15. The limit as x approaches 2 of the function is 15. All right, 54. This one we do our favorite, the F word. The limit as x approaches negative 3 of x squared minus 2x and minus 15 over x plus 3. Negative 3 plus 3 equals 0, not possible. Can't do it. So we're looking for a removable point. If not, it does not exist. Does everybody understand that?
Yes.
All right, so we're going to do the F word. And this is 3 and 5. And 5 is the negative. So now we can cancel it out, and now we can drop it in, because we're now doing the limit as x approaches negative 3 for the value x minus 5. So we're going to get -8. And that's the exact problem I had on the test. Limit as x approaches 1. If we do 1 on this guy on the denominator, I'm going to have 3 minus 4 plus 2. And it's okay. Isn't it? Because it's just 1. It's not -1 or anything crazy. All right. And so this one is a plug-in. So we're going to have the 3 plus the 7 minus the 2. That's 10, that's 8. And then I'm going to have the 3 minus the 4 plus 2, which is a 1. And that'll give me 8. Okay. 56. Find the limit as an average rate of change from C to X. In other words, in this case, our functional structure was for the average rate of change, which is slope. And I'm going to say is going to be f of x minus f of c over x minus c. But this one says from c to x. So we're on the left side. So we have to put c first. Does that make sense? All right. And our function well, that's how I read it. I don't know if I'm right, but we're going to find out. Okay, here we go. And this is a normal parabola, which means it's going like this. All right, a little fast because it's got a 2 multiplier. Sharp, it's a little sharp. Okay, so we want to find f of 1. All right, I'm ready. And we're finding the limit as it approaches this 1. And I'm going to have 6 minus the 2x squared plus 4 divided by the 1 minus x. And that's going to give me a negative 2x squared minus 4 plus 6 all over 1 minus x. All right. This is going to give me a negative 2x squared plus 2 over 1 minus x. All right. I'm going to factor out a 2. So, yes. I'm going to, a negative 2, because I want it positive. I'm going to do a negative, guys. Yes?
On the left, right under the hand, where it says 6 minus 2x squared plus 4, and we do the other way around.
It doesn't matter, because I just wanted to get the numbers together. I didn't change any values. It's a positive 6, and this is definitely a negative 4. That's all I did. I just kept the numbers together. I shouldn't have done that. It messes you up. And I'm going to repair it. I'll repair it right now. I shouldn't have done that. Okay. So that gave me this, right? Yes? Okay. Now, I'm going to factor out a negative so that I can do things easier. A negative on the top and the bottom. Okay, does everybody understand that? Okay. I don't want to throw a curve. I'm going to pull out a negative. So that gives me an x squared minus 1 on the top. On the bottom, I'm going to have a negative 1 x minus 1. Does everybody see what happened? Two negatives make a positive. We're rocking. So this is going to be x plus 1, x minus 1, because we know we have to factor out the bottom. Okay, and I have a 2 in front. So if I put 1, that's going to make it 2 times 2. So what's my change? 4. All right. Okay. This one says f of x equals 5x squared plus x for the point negative 4 and 76, and they want us to find the slope. So we want m tan and tangent line. All right. Okay. So we're going to find our tan first. And that's going to be 5x squared plus x minus 76. Okay? And on the bottom, I'm going to have x minus a negative 4, which makes it, okay? Did I lose anybody? All right. We need factors of 76. Well, I don't know. I'm going to work it out. Okay. 76 is, that's 13, so it's not a 3. We're going to try a 2, and that gives me 38, which gives me a 2 and 19. So it's a 4 and 19, which is exactly what I need, a 4 and a 19. I don't know if this is factorable, though. I don't know. Let me look. 5x squared plus x. Yeah, because it's a plus and minus. All right. So I'm going to have 5x on one and an x on the other. And I need this to be a plus to give it 20, right? And this is 19. And let's see what I get. 19 and 20 is an x. Okay, good deal. X plus 4. Awesome. Okay, so now I've got, this is my tan slope. I'm going to insert my negative 4. I got a negative 39. Did y'all get a negative 39? Are we good? Yeah, it is. Okay, so now we're going to construct the equation of the line. And you use whatever you want. This is what I use. And my point is negative 476, and my slope, my tangent slope, is negative 39. So this makes it a plus 4. Oh, I have to do the calculator. My brain, I'll give you a bogus answer. Hold that thought.
156.
I hear you. 39 times the 4. And it's a negative 156.
Correct.
And add 76. It's a minus 80. Don't forget your X. Okay, everybody good? Questions? Anything that I did math-wise that throws you off? This is for all the cookies. I got to make sure you're clear. All right. Uh, that was 58. Sorry. This, right? Did I skip one again?
57.
That was 57.
Huh?
That was 57. We're on 58 now.
Oh. Oh. Well, no, I got the equation for 57.
Right, but they just wanted to slow. So
Oh, yeah, we're good?
yeah.
Oh, thank God. Oh, equation of the tangent line. And I put it down here so my eyes won't jump.
Yeah, we did 58 and 59.
Equation of tangent line.
Right.
And we're given a point. And we're given a function. No. Oh, it's the same thing, just a different point.
Yeah,
Oh,
that's why I said we did it all.
oh, I'm sorry. I must have hit a duplicate problem.
No, that's great.
And that's why I was confusing myself. I said, oh my God, I jumped again. Okay, so our first step is to find my tangent slope. And that's going to be x squared plus 5x minus my 20 over x minus the 4. Does everybody see where I got that? And we know that putting in a 4 will give me a 0. So we have to do the F word. This is x, and this is 5 and 4, but that's not going to work. So 10 and 2? No. What is it? 4 and... No.
No,
10 and 2. I did get the right portion of that number. It's a positive 20. I didn't mark it wrong.
4 and 16.
Huh? 5. Oh, okay. Let me do that. Okay, I know this is 4 and 5.
Yeah, that's what
It's all it can be. And then, and it's a plus and minus because the last one's negative. So I can do 2 and 10, but I get 8.
I think it's minus 4 now,
yeah.
instead of minus 20.
No, I don't put in the x value. I put f of c.
The C value.
It's a c value. This is c.
Yeah.
The other one worked because it was in, and they gave us another one. I'm not sure. What did they give us over here? Oh, wait.
No, you're good.
All they gave us was 5 as an answer, or no? It says 32. Well, I'm sorry, it does not work. It does not work. So cross that one out. I promise. That is good math on my part. It is not factorable. Let's try the other one. -4. And that would have worked.
That,
Yeah, that one, I think this one will work.
what's the same thing as your top?
Incredible. If I put in, let me check something before we go forward. If I put in a 4, I'm going to have 16 plus 4 is 20. It's 36. It's not 20. The ordered pair doesn't work. The ordered pair has to work. Okay, this is an error on the generator. Sorry.
We already solved 59.
Okay, and we're going to do this one. Let's see. Does that work? -4 is 16 times 5 is,
Yeah, we just did this one, 57. We were short for-
yeah, that one works. Okay, we can do this one. And it's a 5, so it's kind of a little bit varied. Okay. So we're going to do the slope for the tan. And I'm going to have 5x squared plus x minus a 76 over x plus the 4. All righty. Okay. Now, we're going to do the F word. And 76 and 4. 1 and 36, 19. Okay. So I'm going to have here it's got to be a plus. That's 20. And this is the minus 19. Bam. On it. I'm going to have 5 times the -4 minus the 19. This is huge. -20, -19. It's another -39. And the rest you can do. Okay. All right. Let's see, what is this one? Approximate area under the curve using n triangles. And so we're going to say on this guy, 60, it's the integral. And it's from 1 to 6. And we've got 2x to the third minus 1. And we said we would use our calculator. Y'all remember that? Yes. We know that this is the limit as x approaches n number. And in this case, we've got 1 through 6. Oh, it's a sigma, sorry. It's a sigma. I apologize. We want sigma of n equals 1 to 6 of the limit of the 2x cubed minus 1. This changes to this. And we just stick it in the y equals. Okay. We're going to go y equals, going to enter it. And then we're going to do second calc. And we're going to choose number 7. And then we're going to graph it. Well, we have to graph it so we can see it. And then we're going to have the lower entry is 1, and the upper is 6. Okay, make sure everybody's comfortable. All right, we're going to go here. And we're going to clear everything. Make sure nothing is highlighted on top. And we're going to enter the 2x cubed, right? And minus 1. Make sure you put the down arrow that it looks like your argument. We're going to do zoom 6 for starters. And we want it from 1 to 6. So we want to change our window to -3, any small number. And we want 7 because we want 6 to be our stopping point. Does everybody understand that?
Mm-hmm.
And then we're going to see what it does. Okay, we cannot see it because it's so huge. It's very large. So we're going to make it, okay, we're going to say this is going to be a -2, and we're going to make it 1,000. And we're going to make it in scales of 100. Okay, why do we want a scale of 100? Well, the calculator will make every note, but it'll run down your battery. So you want to do the one of least resistance, and this makes it 10. 10 little marks. All right. So we're going to graph it and see if we see it. Yep, we see it. Okay. And I made it too big, but that's better than making it too small. Ready? Second calc. We're going to do number 7. Our lower bound is 1. Our upper bound is 6. And we've got 842.5. And they got 875. I want you to do it this way. I don't want any issue. Is everybody comfortable with that? It's close enough for me. Make it a whole number. We would have 843. And that's close enough. All right. Then, where am I? That was 60, right? No. That was 60. Oh, I did it. Oh, I crossed. Okay. And we're not going to do the n and 5 because those are Riemann sums, and I don't want to do them. I'm just going to have the integration. I just want you to do this. Okay, is that clear?
Yeah.
This is 61, and I'm going to do 62 to make sure you get it. F of x equals x squared minus 3x plus 4. And we have x equals 1 and x equals 5. These are our parameters. So we do our integral from 1 to 5 of our argument. And we're going to stick it in our calculator. That's all I want. I mean, we did play with it in class. Okay, and I'm going to put in x squared minus the 3x plus 4. And then I'm going to graph it. And I need to go zoom 6, sorry. Make sure I can see it. There it is. Okay. And then I'm going to do second trace, number 7. The lower is 1, and the upper is 5. And we've got 21 and a third. And they said 28. Ours is exact. That's all I want you. You'll get that. You'll get this. And that way you don't have any issues. Okay. Let's see. Describes the volume of a cube. We did that one before. Let me go back to 60. Sorry, I skipped that one. I got to make sure I get all of them done. On 60, we have f of x equals x squared minus 9x minus 4 at x equals 7. All right, so we want to first find f of 7. We're supposed to get the derivative. And the derivative is the same thing as f of x minus f of c divided by x minus c. Derivative gives you slope, rate of change. That's going to be 7 squared minus 9 times the 7 minus the 4. That's 49 minus the 63 minus 4. Okay, this is going to be, I'm sorry, negative 18? Thank you. All right, I'm ready. So I'm going to have, for my derivative, f prime of x, I'm going to have my f of x minus my f of c divided by x minus c. And in my case, I'm going to have x squared minus 9x minus 4 plus 18, because I subtract the 18. Is everybody good with that? X minus the 7. All right. So I'm going to have x squared minus 9x plus 14. That is 7 and 2, and they're both negatives. To get a positive at the end. Okay, I'm going to cancel so that we don't get a 0 in the denominator. And so I want f prime of that 7. And that would make it 5. Okay, now I'm at the last one, the cubic. And describe the volume. It describes the volume of a cube. Cube is all sides equal, whose lengths, width, and heights measure x inches. Find the instantaneous rate of the volume with respect to x when x is 7 inches. Again, if we're talking about the instantaneous rate of change, we're talking f prime. And this is 63. So f prime is going to be f of x minus f of c over x minus c. Is everybody good? All right, just little math. Okay, so we want f of 7. That's a big number. What is that? 7 cubed. $343. Thank you. Okay, so I'm going to have x cubed minus 343 over x minus 7. Well, this is a perfect cube. So I'm going to have x minus 7 times x squared, opposite sign, their inner product, plus square of the last, all over x minus 7. That cancels. And so now I know that f prime of x is x squared plus 7x plus 49. And they want the instantaneous rate at 7. So this is 7 squared, 7 times 7 plus a 49. Big number. 49 plus 49 plus, 49. 147. And this is in cubic inches, and it's cubic inches per inch, because it's a volume. And a derivative is per one of something. 1 second, or 1 foot, In this case, it was a cubic against a natural. All right, we've done it. Okay. I will double verify on, the one that makes sure that the ordered pairs work, because if they don't work, it's not gonna work. I've given you all, I think, as clear instructions as possible. Is everybody comfortable? Okay, remember, half of it is gonna be multiple guess. And then the other half will be short work. I have to know you can factor and those type of things. Please read my announcement. I don't want anybody, I will have my extra calculators.
Do we need one sheet of paper for?
No, I'll supply everything. But that's a good suggestion. Thank you.